morning. Now in this video I'll explain how we are getting this characteristics table, actually truth table. So this I have shown you in the ninth question in the previous lecture. This table I have shown, but actually how we got this, that's what I'm going to explain now. So from this only we have actually got this table is the base for this table. Okay, so we know that j and k are the inputs and q of t is the present state and q of t plus 1 will be the next state. Okay, so we have these three can be taken as the condition, so we can write 0 0 0 0 0 1, all the possibilities we can write, right? 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and then 1 1 1, like that we can write. And now we'll look into this. We know that when it is 0 and 0, input is 0 and the present state is 0, the same state will be maintained. Okay, so 0 will be maintained as the next state. Okay, so that means no change condition. Similarly, when you have the 0 0, if the present state is 1, next state will also be 1. Okay, that is called no change condition. So for this 0 0, if q of t is 0, q of t plus 1 is 0. If q of t is 1, q of t plus 1 is 1. So combining these two, here we write it as q of t. Okay, when inputs are 0 and 0, simply we write this q of t plus 1 as q of t, and that is called no change condition. Then we can check for the next two combinations. That means j and k are 1. Here also j and k are 1, but q of t is 0. That means it is present state is 0. Then next state is also 0. Then you check here, present state is 1, but next state is 0. So whatever be the q of t, okay, present state, next state definitely will be 0 whenever you have the input combination as 0 1. Okay, so for this two input combinations we get this as 0. Okay, that's why we have taken this as 0 1 combination. Okay, input combination is 0 1. For this we get whatever be this q of t, we get the output next state as 0. That is called, this one is called reset condition. Okay, so that's what we have seen here. And when you check for the next two more combinations, you see this is our next two more combination, that is 1 0 combination. So whenever you have 1 0 at jk as the input, if q of t is 0, q of t plus 1 will be definitely 1, and if q of t is 1, again this q of t plus 1 is 1. So whatever be the q of t present state, q of t plus 1 will be definitely 1 1. So here this is your input combination, that means 1 0, and definitely this q of t plus 1 will be equal to 1. Okay, this is what we have got, that is called set state. The previous one is 0, so that's why that state is, the state is called as reset state. Okay, now we go for the next two more combinations, like that is j and k are 1 1. Okay, and when you have that input combination, if q of t is equal to 0, q of t plus 1 is equal to 1. When q of t equal to 1, q of t plus 1 is equal to 0. So if you refer these two, they are complement. Okay, so 0 means q of t plus 1 becomes 1, 1 means q of t plus 1 becomes 0. So it is complemented. That's why we have taken this as q of t bar. Okay, that is called toggle. This is how we have got this particular characteristics table. This is derived from this table only. Okay, now we move on to the next one, that is our 10th question we had earlier, that is the excitation table for JK flip-flop. Actually, how we got this excitation table, that is also important, right? So this is derived from this actually. So we got this excitation table from the detailed truth table only. So we know that this is the characteristics table, or this is the truth table. From the truth table only actually we have derived this excitation table. Okay, so but we know that this excitation table gives the prediction of inputs for the given output condition. So q of t and q of t plus 1 are known, then we have to determine or predict the inputs. Okay, so outputs known and we are going to get the inputs. In the previous case, that is truth table means inputs are known, then we are getting the outputs. Okay, right, but this excitation table is derived from this truth table. Now we'll see. So here we have the first combination 0 0, that means present state is 0, next state is also 0. So we'll check for what conditions we have that 0 and 0. If you see, for this condition we have the 0 0. Oh sorry, we have to go for this. Okay, this is 1 0 0 combination, q of t and q of t plus 1. Okay, this is what we are checking. And one more condition is also there here, the same thing, 0 and 0. Okay, so that corresponds to no change condition. Here it corresponds to reset condition. That means you can check here, the input is 0 0 or the combination is 0 1. So from here we have to derive this, isn't it? So we have two combinations for this, q of t plus 1 is 0 0. So when q of t is 0, q of t plus 1 is 0, we have two combinations. Corresponding to that, we have two combinations of j and k. So j and k is 0 0 or 0 1. So on that condition we can see clearly that j is maintained always 0, but the k may be 0 or 1. So that is, we know, don't care condition, right? That can be taken as the x. That's why we got this 0x combination here. This is how we got it. Okay, now you go for the next condition. So if you check this next, this is q of t is 0 and q of t plus 1 is 1. So here we check that output conditions, 0 and 1 at q of t and q of t plus 1, 0 1. So here we have 1 0 1 combination for q of t and q of t plus 1. Similarly here also we have that combination that corresponds to set and toggle condition. Then correspondingly we can go and check with that input combination. So this is our input combination, 1 0 and 1 1 for jk. So okay, so for jk, what are the combinations we have? Either it can be 1 0 or 1 1. So 1 0 1 1 means if you check this j is always 1. Okay, j is 1, but the k may be 0 or 1. So that can be taken as 1x. So this 1x combination is available here. This is how we determine the inputs. Okay, now we go for the third combinations. How do we get the third combination? The third combination is here, it is given as 1 0. So we look for this q of t and q of t plus 1 as 1 0. So here you have this combination 1 0, and here you have that combination as 1 0, that corresponds to reset and toggle, right? So accordingly you check its input conditions. The input conditions are 1 0 and here it is 1 1. So you can write the j and k inputs as 0 1 and 1 1. Now you see here this j is taking two different values, so it can be taken as x, but k is always 1 for this, right? So it is x1. That is how we get this x1. Okay, so this is our answer for the third combination. Now we go for the fourth combination. So what is our fourth combination? Fourth combination is 1 1. That means q of t is 1 and q of t plus 1 is 1. On that condition, here you go and check, this is 1 1, right? Q of t and q of t plus 1. Similarly here also it is 1 1. This corresponds to no change, this corresponds to set. Then you decide, okay, we look into that input combination, that is 0 0 jk and similarly 1 0 for jk. So jk takes two combinations, 0 0 or 1 0. On that you can see that this is 1 0 0 1, two values it takes, so it can be taken as don't care, but j value is always k value is always 0, so it is 0. So this is our answer, x0. This is how we got this 4 combinations, okay, for excitation table. Okay, thank you. Okay, we have to know one more thing that is how to write the characteristic equation, right?